Hello friends, welcome to our video. Our topic is bus arbitration technique. So first we will learn about what is a bus. In a computer system, multiple devices such as the CPU, memory and input-output controllers are connected to a common communication pathway known as a bus. In order to transfer data between these devices, they need to have access to the bus. Bus arbitration is the process of resolving conflicts that arise when multiple devices attempt to access the bus at the same time. When multiple devices try to use the bus simultaneously, it can lead to corruption and system instability. To prevent this, a bus arbitration mechanism is used to ensure that only one device has access to the bus at a given time. There are several types of bus arbitration methods, including centralized and decentralized, and distributed at arbitration. In centralized arbitration, a single device, known as the bus controller, is responsible for managing access to the bus. In decentralized arbitration, each device has its own priority level, and the device with the highest priority is given access to the bus. In distributed arbitration, devices compete for access to the bus by sending a request signal and waiting for a grant signal. Bus arbitration refers to the process by which the current bus master accesses and then leaves the control of the bus and passes it to another bus, requesting a processor unit. The controller that has access to the bus at an instant is known as bus master. There are various types of buses, which are system bus, front side bus, internal bus, backside bus, external bus, and expansion bus.
Hey guys, now we will talk about what is bus arbitration. Bus arbitration refers to the process by which the current bus master accesses and then leaves the control of the bus and passes it to another bus, requesting a processor unit. The controller that has access to a bus at an instance is known as the bus master. A conflict may arise if the number of DMA controllers or other controllers or processors try to access the common bus at the same time, but access can be given to only one of those. Only one processor or controller can be bus master at the same point in time. To resolve these conflicts, the bus arbitration procedure is implemented to coordinate the activities of all devices requesting memory transfers. The selection of the bus master must take into account the needs of various devices by establishing a priority system for gaining access to the bus. The bus arbiter decides who would become the current bus master. Applications of bus arbitration in computer organization. Shared memory systems. In shared memory systems, multiple devices need to access the memory to read or write data. Bus arbitration allows multiple devices to access the memory without interfering with each other. Multiprocessing systems. In multiprocessing systems, multiprocessors need to communicate with each other to share data and coordinate processing. Bus arbitration allows multiple processors to share access to the bus, communicate with each other, and with shared memory. Input-output devices such as keyboards, mice, and printers need to communicate with the processor to exchange data. Bus arbitration allows multiple input-output devices to share access to the bus to communicate with the processor and memory. So we will now see the two approaches to bus arbitration. So the bus arbitration can be approached by two ways. That is the centralized bus arbitration, which is a single bus arbiter performs the required arbitration, and the distributed bus arbitration, where all devices participating in the selection of the bus master. Further, methods of central bus arbitration are as follows. The daisy chaining method. So the first one is the daisy chaining method. It is a simple and cheaper method where all the bus masters use the same line for making bus requests. The bus grant signal serially propagates through each master until it encounters the first one that is requesting access to the bus. This master blocks the propagation of the bus grant signal. Therefore, any other requesting module will not receive the grant signal and hence cannot access the bus. During any bus cycle, the bus master may be any device, the processor, or any DMA control unit connected to the bus. This can be explained through the following diagram. The advantages can be stated as follows. Simplicity and scalability is improved. The user can add more devices anywhere along the chain up to a certain maximum value. As any device has its advantages, it has also cons. The value of priority assigned to the device depends on the position of the bus master. Propagation delay arises in this method. Thirdly, if one device fails, then the entire system will stop working. The next will be polling.
The next The next method is polling or rotating priority method. In this, the controller is used to generate the address for the master. The number of address lines required depends upon the number of masters connected in the system. The controller generates a sequence of master addresses. When the requesting master recognizes his address, it activates the busy line and begins to use the bus. It can be explained through the following diagram. There are some advantages and disadvantages to this method. The advantages are this method does not favor any particular device or end processor. The method is also quite simple. And the disadvantages are adding bus masters is difficult as increases the number of address lines of the circuit. If one of the device fails, then the entire system will stop working.
So the next process is fixed priority or independent request method. So in this, each master has a separate pair of bus request and bus grant lines, and each pair has a priority assigned to it. The built-in priority decoder within the controller selects the highest priority request and assets the corresponding bus grant signal. It can be explained by the following diagram. So advantages are this method generates a fast response, and its disadvantages is a significant number of control lines are needed, which raises the cost of the hardware.
The next type is distributed bus arbitration. It is a type of arbitration mechanism that allows multiple devices to access a shared bus fairly and efficiently. Here are some points explaining distributed bus arbitration. In a distributed bus arbitration system, each device connected to the bus has an arbitration logic that determines its priority and handles its access to the bus. Each device may have a unique identifier, such as an address or code, that is used by the arbitration logic to determine its priority. When a device needs to access the bus, its arbitration logic sends a request to all other devices on the bus, indicating its priority and the type of access it requires. Other devices on the bus can either grant or deny the request based on their own priorities and the current state of the bus. If multiple devices request access to the bus simultaneously, the arbitration logic of each device resolves the conflict based on its priority and the priority of other devices. The device with the highest priority is typically given access to the bus first, but the arbitration logic may also take into account. Overall, the distributed bus arbitration allows multiple devices to access a shared bus fairly and efficiently without requiring a central arbiter to manage access.
Bus arbitration is used in many computer systems and devices to manage access to a shared communication bus. Here are some common uses of bus arbitration. Memory access. In a computer system, multiple devices such as the CPU, RAM, and input-output devices may need to access memory at the same time. A bus arbitration mechanism ensures that only one device can access the memory bus at a time, preventing conflicts and data corruption. Network communication. In network communication, multiple devices may need to access the communication bus simultaneously to transmit data packets. A bus arbitration mechanism ensures that only one device can transmit at a time, preventing collisions and ensuring reliable communication. Industrial automation. In industrial automation, multiple sensors and actuators may be connected to a shared bus to exchange data with a control system. A bus arbitration mechanism ensures that the sensors and actuators can access the bus fairly and efficiently, preventing delays and errors in the control system. Automotive systems. In modern cars, various electronic control units, ECUs, communicate with each other over a shared bus to control various subsystems such as the engine, transmission, and entertainment system. A bus arbitration mechanism ensures that the ECUs can access the bus fairly and efficiently, preventing delays and errors in the system. Overall, bus arbitration is a critical component of many computer systems and devices that rely on shared communication buses. Now, let's see some issues. Bus arbitration is a process by which multiple devices on a bus compete to gain control of the bus for transmitting data. The main issues with bus arbitration are as follows. Fairness. All devices should have a fair chance to access the bus and not be starved of bus access. Priority. Devices with higher priority may require access to the bus more urgently than devices with lower priority. Hence, the arbitration mechanism should ensure that devices with higher priority are given preference over devices with lower priority. Timing. Arbitration mechanism should be fast and efficient to minimize delays and not become the bottleneck in the system. Error handling. The arbitration mechanism should be able to handle errors such as collisions where two devices attempt to access the bus at the same time. In such cases, the arbitration and mechanism should resolve that conflict and ensure that data transmission is not disrupted. Scalability. The arbitration mechanism should be able to handle increased traffic without impacting the system's performance as the number of devices on the bus increases.
So this is about our topic. Thank you for watching this video.